Thanks for coming. Welcome to the session on Java 8 programming idioms. We're going to talk about some of the styles of programming with Java 8. With Java 8, of course, we have this wonderful power to use Lambda expressions and Streams API. And it's pretty easy for us to pick up very quickly how do we go about to use some of these ideas and techniques. But one of the things we quickly run into as developers is, this is almost true with almost anyone, and it's almost true with any technology, is we begin to learn it, then we begin to use it, maybe not so correctly, and then we learn from what we do, our mistakes and other people's mistakes, and then we get better at doing it. So in that regard, I want to spend a little bit of time talking about what would be a better way to use some of these techniques, maybe some do's and don'ts. So I want to talk about idioms. So what are idioms? Idioms in natural languages are things that really trick us. You could take words in an idiom, look up the meaning in the dictionary, and then you realize that it doesn't make any sense at all to put those meanings together because the phrase doesn't seem to really mean anything related to that. And the reason is idioms often are structured by culture and some stories and events that have happened. And then, of course, generation after generation, people use those idioms. And if you're local to that culture, if you're local to that language, those idioms mean something to you. But for somebody coming from another language, it can be really confusing. Even for English, if you really think about it. There are idioms in different parts of the world that speak English, and that's not all the same. And so when it comes to programming languages, similarly, there are idioms for languages as well. But in this case, I want to talk about certain ways we can improve the way we write code in Java 8. Now, quickly, I'm not going to spend time on introduction, but we could use Lambdas, we could use method references, we could use Stream API. Java 8 was a very significant update in the Java world, and it fundamentally changes the way we would write code moving forward. We're used to writing imperative style of code in Java, but now we can also use more of a functional style of code as well. So with that said, let's talk a little bit about what are some of the ways in which we can adopt using Java 8 in a much better way. So the first thing I want to start out is, I want to talk about some idiomatic practices. And the first one I want to talk about is to think more declaratively before we think functionally. Now, most of us, I would argue, are very comfortable programming in the imperative style. If I give you a problem to solve, within minutes probably you can solve the problem using the traditional for loop, for example, or using the ways we have been doing it so far. But if I ask you to solve the problem using a functional style, if you're like me, you're probably going to struggle to do that. Because we've been wired so deeply in thinking in the imperative style, it's really not so natural and easy for us to think in the functional style. But what I realized over time is, if I, instead of forcing myself to think in the functional style, if I instead make myself think about declaratively, that's a much natural transition towards the functional style. So what is the difference between imperative and declarative style? In the imperative style, we tell what to do, but we also spend our time and effort telling how to do it. In the declarative style, your focus is more so on the what you want to do, and you let the underlying libraries figure out how to do it. So for example, let's think about an example of how this would make a difference in terms of thinking declaratively. So let's say for a minute we have a collection of names, let's say. So I have a string, let's say names equals, and then I'm going to say in here arrays.asList, and I'm going to create a bunch of names, let's say, for a minute. So in this case, let's say I have a bunch of names I'm going to bring in from here, and these names I'm going to create just have a bunch of interesting names in it. But my problem at hand is, I want to say, find out if Nemo is in this list. So how would I go about doing this? Well, we're used to the imperative style. So you would start with Boolean, and you would say found is equal to false to begin with. And then, of course, if found, at the very end you can say proudly, we can say found Nemo. Well, if it's not found, of course, you could then say else, and then you could output, Nemo not found. Well, in this case, of course, we need to still work through and, decide whether Nemo was found or not. So what do you normally do for that? The worst case scenario is you start with int I equal to 0, I less than. That's a lot of work to do, isn't it? Or you could say, in this case, string name, And names comes from the collection of names. And then you would say if, name dot equals, and then you're looking for this Nemo, and then you would say found is equal to true, and then you would do the break on it. And that's how you would be writing the code. And Nemo was found. But if you look at this code, there are several things fundamentally tedious that we do here. The very first thing is, notice we had to set up a variable called found. What is that called? These are called as garbage variables. Garbage variables are variables you're forced to create, but they don't really contribute to the real problem at hand. They're kind of accidentally in there. In fact, the chances are you wouldn't call it as found. You probably called it temp or T to show your contempt that you don't deserve to exist here, right? And that's how we feel about variables that are garbage variables. And then you loop through, but notice you had to control the looping. You had to break at the right point. And if you don't break, of course, you're going to continue doing more loops. And of course, if you have a very big collection, may not give us a good performance. So you are dealing with every single detail of the code. That is what basically imperative style of coding is. Imperative style code is when you are responsible for the whole thing. But at the beginning, it may appear to be a smart idea. Hey, this is great, I get to do everything. But after a while, you realize that's a burden you have to carry. And that's not going to make you very productive. So what you really want to do is to focus on the big picture, the what question. So what are you trying to do? So notice, here we have this code, which is sitting right here in front of us. Let's just go ahead and comment that out for a second. Now, let's do the same thing again, this time though. I'm going to say if, well, let's actually take this part alone for a second. And I'm going to go ahead and take this code, but instead of this garbage variable found, I'm going to say names.contains, and then simply ask for Nemo. Well, if you notice, that contains accomplished the job for us. We didn't have to sit there and loop through and do the work. Now, in this case, this might be a very trivial example, and you may say, gosh, that would have been really easy. But the point I'm making is, that's exactly what we need to do for every single problem we face. So when you look at a problem, it's okay to write it in the imperative style. There's nothing wrong with it. But once you write in the imperative style, step back, take a distance and say, what does this code do? If you can put in words what the code does, it gives you a clue about what kind of functions you want to go find. And that can be a very useful way to discover the declarative style hidden in the code. So my recommendation generally is, if you're transitioning into programming with Java 8, don't force yourselves to think in a functional style. It can really be frustrating when you do it. And when we get frustrated, when we feel that we can't achieve it, it demotivates us to getting things done. In all honesty, I programmed for decades in imperative style. And if you give me a problem, my mind will go immediately think about imperative style because that's what I'm used to. And I'm going to say today I am at about a 40 to 50% of success rate. If you give me a problem, 40 to 50% of the time, I can figure out a functional style right away. The other 50 to 60% of the time, I got to sit there and struggle with it. I got to think about it. I got to think about it for a few minutes. The worst I've seen so far is I was on a flight. It was a 9-hour flight. I took a problem, wrote the code in imperative style within about 15 minutes, and I wanted to write this in functional style. It took me a good 8 hours on that flight. Forget about in-flight entertainment. When you have code like this is amazing, right? And I spent 8 hours on this code struggling to write this in functional style. At the end of 8 hours, a little light bulb goes in my head. I'm like, oh wait, I could do this. And then I write the code, and then they say hindsight is 20/20. I'm looking at this code, I'm like, why was this not obvious to me? Why did it take me 8 hours to figure this out? And that's okay. It's okay to take the time to figure it out. And sometimes it may not be today, it may be tomorrow, it may be a week from now. It could be a case where you don't know how to do this, but you just enter into a conversation with a colleague and say, how would you solve this? And as you're discussing it, it may click in. But one of the approaches I found to be really helpful is, rather than trying to force my mind into thinking functionally, if I step back and ask the question, what am I trying to do? And keep asking that question, then I'm thinking about being declarative, and it usually ends up being a little bit easier to find the code that would help us solve the problem. So let's move a little further. one of the beautiful things we can do here is we can apply the so-called function pipeline pattern. Now, if you look at the code that you do, what is it that you normally do? I have a challenge for you, right? When you get back to work, I want you to do this little homework. And just take your code base, your code in your project, in your company, and do a quick grep. Do a search through your entire code base and count the number of times you see for in the code. You would be shocked, isn't it? Just take it as a homework. Try this. And find out how many times you use for in your code. It is shocking, isn't it? Every corner we turn, we keep using for loops. Occasionally a while loop, but mostly a for loop, right? And this is really, really horrible because we've been using it along. But we want to really focus on applying a function pipeline pattern if we can. So what does it mean to think of a function pipeline? Let's look at an example of this. So I want to start over here with a little example of a create person. So this function is creating some people. You can see there is a name, there is a gender, there is an age. And what I want to do is the following. So given these, I'll say list of person, I'll call it as people, equals to create people. So I got a list on my hand. But what I want to do with this list is, I want to go through all these people, and let's say I want to pick from this collection only the first person who is a male and who is, let's say, older than 30. Let's say older than 20, let's say. So I want to say, find the first male older than 20. So what would you do for that? First of all, you would say person, and then you would say found, and you're going to set that variable. In fact, chances are you would say equal to null. Null is a smell, isn't it? So that's a smell we have to deal with in the code to begin with. And then you do something even more, smelly. If found is not equal to null, you're going to print the name of the person because it's possible the list has nobody over than 20 or nobody who's a male. And then if it's found, if it's not equal to 0, you would say the person who you found and you would print the found. Otherwise, you may say output, and in this case, you may declare something like, for example, no one found. So you could take the effort to do this. But this brings back the exact same question. How do you go about processing this in here? So right now, of course, nobody is found. But I can say for a person coming from people, and what am I going to do with this collection? Well, given this collection of people, I can then say, well, first of all, if the person.getAge is greater than 20, because we do want people who are older than 20, and then I could say person.getGender, and then we could say, for example, in this case, is equal to gender.male. Well, then, of course, I better break out of this loop because we found the person we were looking for. And then we could say found equal to the person at hand, and we could run the code through that. And it says that's Paul, and that's a male, and then it's 32. But notice that for loop and the break and all those good stuff we do. This is a very consistent way that we often code. So how does this feel to be coding like this, where we keep using the for loop, right? We don't even think about it, right? Our fingers normally just type for loop. So this is like you hear a knock on the door, you open the door, and there's a guy standing there with the hammer. And you say, who are you? He says, I'm here to fix your kitchen. You guys called, right? And you're like, okay, you're here to fix the kitchen. Where are your tools? He takes a whack at the door and says, I don't need any stinking tools. I got this hammer with me. You probably let the guy in the house and you run out and call the cops, right? Because it's dangerous to be here with the guy with the hammer. This is called a for hammer, and we've been using this for hammer everywhere we go. Let's see how we can do the same thing differently now. So what we can do here is, let's again comment that part out, and let's redo this. But this time around, I'm going to say, well, given the collection of people that we have at our hand, which is up here, so we got the collection of people, and I'm going to start with output, and I'll say people over here, and dot. Well, what am I interested? First of all, we get a stream. A stream is an internal iterator. It's a fancy, nice little iterator that allows us to iterate over every single element. And then I say filter. And what am I filtering? Give me a person whose age is greater than 20. And then the next one, what we're going to do here is yet another filter. And given a person, I'm going to say person.getGender is equal to gender.male. So now we have taken the person and we have taken the person who is a male and greater than 20. In fact, in this case, let's just change the problem a little bit. I just want the name and not the entire detail. I could even perform a map. In the older code, what I would have done is, I would have said string found equals to null. That didn't change. But what I would have done here is, I would have said person.getName, and that's how I would have added that. Well, the same idea here, I'd say map, but here I say person, and then I say person.getName to get the name of the person that I'm looking for. And then, of course, I don't want all of them, so I'm going to say find first. So find first says, here you have a collection of all these objects. I don't want all the people who are older than 20 and who are male, but I only want the first person in this ordered list. But there's a problem though. It is quite possible that there may not be a person. So what Java does is something really smart. When I run this code, you would notice it says optional Paul. It says optional because there's a reason why you set this to null in the beginning, right? Because it may not be there at all. And that's why you had to come and do a null check. Well, that's exactly what this code says. Hey, look, I can give you the first person's name, but it's possible that I don't have a person to give you. It could be a collection with no males or a collection with nobody who's older than 20. Well, then you say, all right, if there's a name, give it to me, please. Or else, what do you want to give? I'm going to say, or else, no one found. So this becomes a very concise way to write exactly the code we wanted to write. So this is the functional approach, as you can see. Now, in this case, notice, we're not using the for loop. But what are we doing here? We're using a filter, and a map, and a find first. Oh, wait a minute, instead of using just one for, we're using a lot of these things. I call them the tools of our trade. Again, you hear the knock on the door. You open the door, there's a guy standing there. You say, who are you? He says, I'm here to fix your kitchen, didn't you call? And the guy has a tool bag. You say, yeah, come on in. And the person lays down the tool bag in the kitchen, removes the tools out, and what do you see? You see a hammer, you see a little chisel, a screwdriver, a wrench, and you say, look at all these tools you have. And the person says, yep, those are all the tools of my trade. And you ask the person, are you going to use all of those tools? And the person laughs and says, no, the person who uses all the tools is called a consultant, right? We only use what really makes sense. So the point really is, you pick and choose what may make sense. And so, yeah, I'm going to use this tool called the filter tool because it makes sense in here. I'm going to use the tool called the map tool because it makes sense here. But there are other tools in my tools bag, but I don't care to use because those are not useful right now. So that's basically what you're doing. You have just used these little tools to get your work done. And when you run this, you can see that this is producing the result you wanted. Now, this is a function pipeline pattern. It's a function pipeline because don't look at the code, look beyond it, read between the lines. Notice how this flows through from you take a collection of people, you get a stream out of it, then you get a collection of all the people older than 20, then you get a collection of only males older than 20, then you find the first person, then you get the name, and you're done. So it begins to flow like water flows through a pipe. That's why this is a pipeline pattern. So when you're programming in the functional style, you are building the pipeline. If you Google for this, you will find a really beautiful article written by Martin Fowler. He calls it the collection pipeline pattern. So we are at a cusp of a major shift in the way we're going to be writing Java code. We're going to go from writing the traditional for loops that we have written so far so many times to start using the pipeline pattern. So in the traditional approach, we've been using so many for loops. I gave you a little homework earlier to go look for the number of times you're using the for loop. In about 5 years' time, when you look at those code, you're going to see a lot more of the pipeline in your code rather than the traditional for loops. So that's a very major shift you're going to see in the way we're going to code. We're going to use this pipeline moving forward. So more and more, we're going to be using this pipeline. Now, thinking about this, It'll give us a better way to think about the problem. So first I said, think about it declaratively. Well, yes, I'm thinking declaratively. Then try to visualize a pipeline. Think about the problem as a series of transformations in your head. You're saying, here's the given problem. Here's the result I want. What kind of transformations I can perform to go from the given problem to the given result. So you need to be able to visualize the pipeline in your head, and you say, well, given this particular set of collection of data, here's the result I want. What are the intermediate pipeline steps I can take in terms of these little tools and transform the input towards this output? That can give us a nice way to think in a functional style. So think along the lines of this pipeline pattern, and that can help you quite a bit. The next thing to think about is we need to really care about code quality. Code quality is extremely important. When you write code, you are not writing code for the compiler to compile alone. Remember, a compiler is a machine. A machine can do a lot of things. There is a difference between humans and machines. Machines are really good in doing what we are not good in doing. We are really good in doing what machines are not good in doing, at least now. So the point really is, we need to also think about the humans who are reading your code as well. So when you write code, there is a culture of writing code in a cryptic way. But we need to change our minds. We should take pride in writing code that others can actually understand. And we need to place value in that. So when you write code, if you write it very cryptic, and if your friends, your colleagues look at it and say, my gosh, I don't understand what this code is doing, that's not something to be proud about, right? If you're an intern in a company, you go look at their code and you're scared like hell. And then you go back to college and say, the company I interned with, they are very smart people because I didn't understand anything they are doing, right? That's not a sign of smartness. That's a sign of stupidity, right? Because Einstein said it takes a touch of genius and a lot of courage to make things simple. And if you're really making things complex, any fool can make it complex. It actually doesn't take much effort to make things complex and absolutely ridiculous. But if you want to make things really easy for other people to understand, you have to make it simple. You got to put the effort to do that. So when you write code, you have to care about this a lot. So on that front, I want to emphasize one thing. When you write the code, so here is a nice, beautiful pipeline. The question often is, rather than writing this code like this, can I write the code like this? And you will see a lot of developers do this. You will put a dot and a dot and a dot all in one line, like this, right? In fact, I will remove the wrapping to make it even more fun. So let's remove the soft wrapping. Well, this is going to be one-liner where this is going to keep going on the same line like this. Now, to be fair, this is a very long font I'm using, but nevertheless, in general though, the code is going to be like that, isn't it? So if you look at this, dot stream, dot filter, and then you keep going this way, and then dot filter, and then dot map, and then of course, find first or else. So raise your hand if you have seen code like this before, where a lot of dots are on the same line. We all have, right? So the question is, should I put multiple dots on the same line? And I have an answer for it. Put multiple dots on the same line if you hate everyone that you work with, right? That is the only reason to do it. So by writing that you're telling your colleagues, I hate you all. I don't care about the fact that you don't understand this because I am that cool, right? But if you care about the people that you work with, you have to step back and ask the question, have I made it easy for others to understand the code, or have I made it hard? When you write English, or any language for that matter, you write sentences. What is a sentence? A sentence is a thought idea. And then you build the next sentence. That period or a comma that you put tells the reader, I have given you a thought, register in your mind, I am ready for the next one when you are ready. You write short paragraphs. At the end of a paragraph, you're giving a mental reset to the reader. I have given you a chunk of thought, register that. Take a breath, think about it, move on to the next paragraph. You know, when I read articles, when I read books, I not only read them for the pleasure of learning the content, but I am beginning to enjoy more and more the author as much as the content being written. And I don't have patience. I'm probably one of the most impatient people I know. I would take some books, and within minutes I'll throw it away and walk away and do other things. Then there are other books I take and I could not put them down. I'll be reading and reading and reading. And then I would pause and ask the question, why am I reading this book? Well, for one reason, the content is really superb. But that's not only part of the reason. The other reason is the author has really cared about me, the reader. They have presented in knowledge chunks, and they make it easy for me to read, digest it, appreciate it, and move on to the next level. And that's when I say, thank you for writing it for me. The author did not write for them. The author has written the code for me, the reader. That's exactly what our job is when we write code. We write the code for the person reading the code, not for ourselves who are writing the code. We need to optimize the code for reading, not for writing. So in that case, if I look at this code, I'm straining my eyes and my head to know when to parse and where to parse. Here is a stream, all right, got it. Now I start a filter. Well, where does the filter begin? Where does the filter end? I got to keep scanning, and I say, oh, there. That's when the filter finished. Here's the next filter starting. Keep going. Oh, there. Oh, that's not the end point. Keep going then. And then, oh, there the filter finished. I'm ready for the next map. You have increased the cost of understanding this code, the burden, the effort. Go back to this code now. We won't do this, of course. And so let's go ahead and remove that for a second. Let's go back here. Now notice what the cost of this is. Given a collection of people, I'm going to get a stream out of it. Okay, that's awesome. What are you doing next? Filter. Oh, you're going to select some data and not others. Filter what? People older than 20. Okay, given all the people, I want people older than 20. But only the male. But then only their names. And then the first person. Notice how every single line gives you one single thought. So this is one of the conventions we have to follow in Java, is never put more than one dot on the same line in a function pipeline. You want to move from the top to the bottom, then you have made it easier to understand the code. The good news is there are IDEs available today. When you say use Java 8 convention, and when you hit the shortcut to reformat your code, they will do this automatically. If you tell me my IDE doesn't do this, I got a recommendation for you. Go get a real IDE. So the point really is you want to be able to write the code in a way people appreciate it. So the real power in what we do is in making things easier for others who read our code, not to make it cryptic. And that is something we need to really value, so make the code expressive, make the code easier to understand. The next thing I want to talk about here is, you want to iterate over a range of values, let's say. So what do I want to do? Maybe for a range of values, let's say starting with, 1, I want to do the following. So I'm going to say in here, in fact, we'll come back to the example later. So what I want to do here is, I want to say for int I equal to 1, I less than 10 I plus plus, and what do I want to do in here? Maybe I want to do some work for every single element in this collection. I want to say, the value is, and I want to print that value out. So clearly in this case, it printed values 1 through 9. You could do other things here too. You could branch this off as a task for execution in a completely different thread if you wanted to. And clearly you could do that as well. But it doesn't matter what you do inside of this. But again, notice that for hammer. And we are saying, I want a loop, I'm going to start with a for. But we have to ask a question a little differently. Look at this for a second. Let's put this in English. Look at that code for a second. What are we doing? What is the question? What are we doing here? What's that word? Our word is range. We are doing something for a range of values. The minute you verbalize it, right? Speaking out is a good thing. It's perfectly okay to speak when speaking things out is a remarkable way to make our brains clear out things that is stuck. So if you say, what am I doing here? And I am working on a range of values. Okay, that's a clue here. Maybe I can look for a function that gives me the range. So now what I'm going to do here is, I'm going to bring in java.util.stream, and then I'm going to rewrite this whole thing again this time in a more idiomatic style. Int stream dot range from 1 to 10, and then for each, and then I'm going to say, given an element I want to output, in this case, well, the same exact thing we did right here. Just grab that part. The value is, and I can just print it. So when I run this code, what is this going to do? Well, we are starting with the range of values, int stream.range, for each I, system.out.println, and the value is, and then you're asking it to just print that value that we have with us. So this essentially is going to give you the same output. But we are using a function called the range function in the int stream. Now in this case, of course, the range function goes from 1 through 9. If you look at the output, that's exactly what it did. It stopped at 9, which is what this is going to do also, isn't it? Starts and stops at 9. Had you written less than or equal to, then the top one would have gone not till 9, but till 10, as you can see in this output. Well, clearly, I want to be able to go with that also. So one way to do that is to say 11 over here. But that doesn't feel good, because we're saying put one more, or what you can do is you can say range closed, and that goes from 1 to 10. So range will stop one before the endpoint. Range closed will include that as well. So if you wanted to use a less than, use range. If you wanted to use the less than or equal to, use range closed. So once again, rewiring our minds to think about, I'm iterating through a range of values. Maybe I can start using the range function to do the work, and then you can start working through that particular sequence. So this again is something we can do, is start working through a range of values that we can work with. The next thing I want to emphasize is that we should treat lambdas as glue code. Let me tell you what I mean by that. I do random tweets. I'm a programmer, but I'm a full-time programmer. What that means is every hour of the day I'm thinking about programming. That's how I'm wired. And so one morning I was thinking about something, and I randomly tweeted. And my tweet said, lambdas should be glue code, 2 lines may be one too many. And I just made this random tweet. And then about an hour later, somebody tweeted back to me saying, can you explain this, please? Can you give a reference? Because I'm looking at a code in front of me, and it's a monster. And I want to know why you said this. And his tweet looked so genuine to me. So that evening when I went back to the hotel, I spent 2 hours writing a blog. And then I posted the blog. I tweeted back to him and said, take a look at this blog. And a short while later, he replied back saying, you really created a lot of work for me this weekend. That's all he said. And then the weekend goes by. On Monday, he tweets back saying, I really thank you for writing that blog, because I spent the entire weekend refactoring my code, and I'm proud to tell you, finally, I'm able to understand my own code. And this is something we need to really think about making better. I was teaching a course on Java 8 in London, and when I went there to say, I'm going to teach Java 8, they've been using Java 8 for a while. They wanted to go through a formal course on Java 8 so they can get trained on it. And I started teaching, and one of the guys in the class said, we all hate Lambda expressions. I said, that's very motivating. Thanks for having me here. And then as I was teaching it, I mentioned this exact point, Lambda should be glue code. And he said, come over here, I have to show you something. And he takes me to his computer, and he said, the guy who wrote this code is not in the room today. He's not in this course. But I want to show you what he did. And he opens up his source code, his production source, the one that I have in production, right? He shows me the code. And they have functions that are huge, where the lambdas in the functions, each one of the lambdas are 150 lines long. And he showed it to me and said, now you know why people hate lambdas in this company. Because to them, lambda means unmaintainable code. And then he didn't stop there. He brings up the code coverage tool, and then he shows me the code coverage, and the places where there are lambdas, that is red in the coverage tool. And this is something we need to pay attention to very quickly. There are times when we start using some practices, some tools, and at some point we have to ask, are we using this tool the right way? Or maybe we're not using the tool the right way. Maybe we should go ask somebody and say, what am I doing here that I should be doing differently? That's something very important for us to think about. So in that regard, let's talk about something here. So I'm going to just see if I can Google for that. Lambdas are glue code. That's all I'm Googling for. Lambdas are glue code. And you see the blog I'm mentioning too. So if you Google for lambdas are glue code, that's exactly what it is. And here's the tweet that I mentioned earlier. A lambda expression should be glue code. 2 lines, maybe 1 too many. So when you're writing a lambda, you need to be very careful about it. So as I'm writing a lambda expression, am I writing a lambda which is really small, or am I writing a lambda which is turning into a monster? Now, why should I not be just, be happy to write lambdas, which are multiple lines? Let's take a look at an example and then come back and revisit this. So let's say I am writing a piece of code, and in this case, I want to do a few things, let's say, with this piece of code. I could be saying int stream.range from 1 to 10, for example. Then I could say for each, but I want to do some work with each of the elements. So I could put a little arrow right here. Then I could put a little curly. That's a first sign of trouble. Then I could start writing 1 line at a time, and this quickly becomes many lines. Now, this lambda is going to be several lines long, and the minute you put a curly, lambdas require you to use semicolons. Well, notice lambdas did not require semicolon a few minutes ago. Now you will start putting semicolons within this. You will also start putting, as you write this, you may have to put a return in the end if your lambda is returning a value. If your lambda is not returning a value, obviously you wouldn't put a return. But if your lambda was returning a value before, like you were using a map function, you'd have to forcibly put a return. But that's only the beginning of the problem. The first problem here is, notice if you had done something like this. If this was in the middle with the map, and then you come here, and then you say dot over here, and you're going to put a for each. And to add insult to injury, you're going to put more code right here. Now, this is going to become really unbearable, right? Because if you are the developer who should read this code, what are you going to do? You're going to come in and look at this code, and you're going to scratch your head and say, I need some help. I need some coffee. Forget coffee. I need something stronger than that. And then you're going to reach over for injection. Okay, now I'm ready to handle this code, right? That's how it feels. Because this code has turned into a burden we have to carry. That's pretty difficult to work with. So what you want to do is think about a lot of different things that's going to go bad here. Let's see why. What are the reasons why this is a bad code? Well, the very first reason, I'm just going to use this blog here to just leverage what I want to talk about. So in this case, if you notice, I have a numbers for each. That's a sweet little code that's sitting in there. One little thing we do, and we are done. But then if you notice right now, I'm going to have to do a little bit more work here. So notice numbers.for each, then a curly, and within that I put an entire for loop to do some work, and I end it here. There are some few problems with this code. First, the code is hard to read. You're looking at it and saying, okay, what are the things you're doing here? You're trying to understand the different pieces together. It's no longer intuitive. It's no longer something you can understand very quickly. You got to sit there and stare at the code for a few minutes. So the code is hard to read. The code is very noisy. It's verbose, right? There's too many things going on in this code. The code leads to duplication. If the same thing you need to do again, what are you going to do? Well, that lambda is not reusable. And you're going to use a copy and paste. Now, not only is this monster, That monster has created more babies now. That's the worst kind of monsters, isn't it? Because they just keep growing. You go to lunch and come back, and the monster has given birth to more babies. And you know this is the time to update your resume, right? Because this project is not going to be maintainable anymore, and that's going to be really frustrating. So that's where it leads to more duplication of code as well. That becomes really hard. And talk about testing. It's hard to test it. How do you test the functionality of that Lambda? Well, you can't reach into the Lambda so easily. The only way you can reach into the Lambda is by calling the outer function you are using, and that's not going to give you much ability to do that because the permutation and combination you have to use to test the different parts becomes really hard. So what is the answer? The answer is the Lambda has to be a glue code, just something to just tie things together. You don't want to put a lot of logic in a Lambda. If all you're doing is, I'm getting this value and I'm going to do a little bit of work and I'm going to pass it to this other place, that's perfectly fine. But if you have to do a lot of work, take that chunk of code that you were going to put in Lambda and simply roll that into a function. And by writing it as a regular function, you can test that regular function very easily. And once you test that regular function easily, you can have a fairly good coverage on that code. You can write more tests on it. Because it's a separate function, you can reuse it. You don't have to duplicate it. So that becomes a lot easier as well. And as a result, then in the Lambda, you just call that function, which is exactly what I'm going to do here. So if you notice, I took that code within this curly, and I rolled it into a count factors. All of a sudden, notice, the Lambda didn't have a name, but this one has a name. So we can even identify what is that abstraction, what it's doing. So I wrote a function called count factors. And then once I write this function called count factors, if I want to refactor it, I can refactor it tomorrow any number of ways. But the more important point here is you are coming in here to the code. And in this case, all I'm going to do is simply pass count factors to that function. That function, originally the one that had the big Lambda, now became very concise. It's not noisy anymore. It's easy, it's expressible, it's easier to understand as well, and that becomes a lot better to work with. So the moral of the story is treat Lambdas as glue code, 2 lines, maybe 1 too many. You don't want to create monstrous Lambdas. So anytime you see somebody put a curly to create a Lambda, it's okay. You know, there's nothing, it's not about being bad or anything. You just say, okay, thanks for making this work. Now let's refactor it, make it better, and let's roll that into a separate method and just call that. That way the Lambda doesn't become multi-line, it becomes easier to work with. And that is something we have to do as much as we can, is to treat Lambdas as glue code and not let it go out of hand. So moving a little forward, use method references wherever possible so that you can avoid using unnecessary variables when you're writing code. So what does that really mean? Well, let's take a look at one little example we did that we used where there are times when you can use a method reference, there are times you cannot. So what is a method reference? Well, a method reference is, simply put, a substitute for a Lambda when your Lambda is not doing anything really significant. So let's look at this example to understand what we could do. Let's go back to this function pipeline. And in the function pipeline, there are a few things I want to mention here. The first is, notice I called it a person. This is another thing I would recommend quite often. Give nice names for your variables. Again, this is an area where we have to take pride. You could call it P, you could call it K, you could call it Z. But if you call it person, you're telling what you're dealing with. Otherwise, you look at the code and you say, huh? What does this mean here, right? And then you discover, wow, Z here is person, right? You don't need to go through that kind of effort and be happy and celebrate. And then you meet your colleague at the coffee machine and say, hey dude, that's really awesome. I found that your K actually stands for person. So tomorrow, find a different variable for me, right? We don't need to be playing these games with each other. We got production code to release in the meantime, right? We can be more intellectual. And that's exactly what I want to emphasize. We can be more intellectual. We don't need to be placing these silly things for each other to discover. So what am I going to say? Well, look at this Lambda. It takes a person But it is actually doing a little bit of work. It says, I want to get the age of the person and compare it to 20. Okay, there's a little work going on. What about this one? This says, given a person, get the gender and compare it to male. Okay, there's a little bit of work going on. But look at this particular lambda. What does it do? Nothing really much at all. It says, given a person, I'll call the get name. And that's all it's doing. I have a special name for these kinds of lambdas. I call these kinds of lambdas as office space pattern. Remember seeing the Office Space movie? What is the one cool thing in that movie? Tom, what do you do in this company? I take the requirements from the business people and I give it to the programmers. Well, do you do anything with the requirements? No. I take the requirements from the business people and I give it to the programmers, right? Well, there's happening in this. That's exactly the whole point, is this lambda is not doing anything useful other than simply transforming the call. If your lambda is doing something even little bit of work, like the get age compare or the get gender compare, you cannot use a method reference. But if your lambda is simply a pass-through, where all that you're doing is you're calling a method on it, or you're just passing this to other functions, then what you can do is you can replace that with a method reference. So in this case, I'm going to say this is a person class, so I'll say person, and a double colon, and then I will replace it with a get name, and you can see the code still works. So this is called a method reference. So a method reference is simply a reference to a method, and you can either use a lambda, or if a lambda is absolutely trivial, you could just go ahead and use a method reference instead as well and get away with it. Now this, I have to admit, method references take a little bit of effort. I'm going to say it's generally easier to read a method reference as a programmer, but it's a little bit more effort to write a method reference. And it may take you a little bit of practice. It may take you a few weeks to a few months to get comfortable to write method references. Because some method references may appear a little bit too complex for you, and it's okay, take the time to learn that. So it's easier to read generally, takes a little bit more effort to write them, but over time you can do it. The cool thing about it is some really good IDEs will also give you a suggestion for replacing your lambdas with method references. When you click on that light bulb, and before you could blink your eyes, it'll swallow your lambda and replace it with method references. That's a nice way to learn as well. But again, this is also one thing I really like. I often sit down with people and say, take a look at this code, let's refactor it together. That can be a really good learning experience as well. So take the time to replace with method references where possible. And there are some other benefits as well in terms of how the bytecode may be generated if you use it. But that brings up the question. And this is another person who tweeted me and asked the question, hey, do you think I should really put the type information in lambdas because I'm used to giving type all the time, or should I just not put the type in the code? So that's another thing to think about, is I would rather give a descriptive name and not provide the type where possible. So for example, imagine in here, I am going to write this code. I could have written this as over here, a person I, like this. But in this case, this type person is absolutely redundant. And we can avoid providing this type detail. Once again, if you ask me, is it really good to provide it or not, I'll bring up that other blog I talked about for talking about why I think that may not be necessary. So this blog here is, again, in response to somebody who asked me, and I'm going to say get comfortable with type inference and avoid single letter parameters, parameter names. So here's an example. Look at that filter p arrow p.is resident. Raise your hand if you've seen code like this one. Yeah, we all do this, right? We put arbitrary characters. It could be P, it could be Z, it could be S, it could be, whatever it is, some letter arrow. And you look at this and say, what in the world is P? Is P a patient? Is P a physician? Is P, what is it? Well, P stands for pathetic, right? That's what we use the variables for because we don't know what this is really. So we can be guessing, okay? I don't know what P is. Hey, here's an idea. Let's say person P. Now this feels so much better, isn't it? We know that P is a person. But what kind of person? Is it a friend? Is it a mom? Is it a dad? Is it a cousin? We don't know, but it's a person, right? Well, that's still is not very descriptive after all, but it's a little bit better than the other one. We could go a little further. Now look at this beautiful code. P is resident. P get cars. This has to be C. And then C dot get license. This has to be S. S dot to uppercase. Now you're sitting there and scratching your head. What the heck is P and C and S? And sometimes I feel like people are absolutely waiting to give random names just to mess with me, right? Hey, Venkat is going to read the code. Let's go find out some random characters to put in there, right? And then you're sitting there and struggling. It's like, what does all this mean? Well, let's try this again. Person dot is resident. Person get cars. Car get license. License plate number. Hey, you know what? I don't need the type anymore because the names of these are telling me what these stand for. So by using a more descriptive name for parameter names, we can ease out on the type most of the time. So in other words, I would get comfortable with type inference and by avoiding single letter parameter names as much as I can. And so if you're using a type as a crutch, instead of giving a better name for variables, I would encourage you to really use better variable names and rely less on type information. And the type becomes redundant in those cases. Java will not require type from you most of the time when it comes to lambdas. And the occasional time when it does want the type, feel free to give it, but don't have to really give it all the time. So, moving forward, get used to cascading lambdas. So what does that mean, cascading lambdas? Well, there are times when you could write a function that might actually be returning a lambda to you, or a function to you. So for example, what if I were to write a function in this case? Let's go ahead and say I want to bring in a function star, and then I'm going to say in here a predicate and a function which is going to take an integer and returns a predicate, which in turn takes an integer. And in this case, I'll say, call this function as check. And it's going to take, let's say, a value as a parameter. So what I'm going to do here is, I'm going to return a function after all. So I could say, return new function, which takes an integer and a predicate, right? Which itself takes an integer. So in this, how do I go about implementing this one? Let's start with the little baby steps. So this is a function, but it's going to return a predicate. So I'm going to say public, and the function itself is going to return a predicate. So integer and apply, and this is going to take integer, so integer value. And in this, of course, I could then say return new predicate, and this predicate is going to take an integer, and this would, of course, have a test method, so public void, public boolean test, which is going to take a value, we'll say integer input. So I know this looks a little complex at this point, but essentially we are returning a function, which in turn is going to return a predicate, which in turn is going to do some testing. But you can start refactoring this kind of code. When you start refactoring this code, you might get to a point where you can say something like this. You could say something along the lines of return. Well, this is going to take a value as an input. So we'll say value. Obviously, this should be a value different from this one. So we'll say, in this case, some pivot, let's say. So it's going to take a value. Well, the value, what is it going to return? It is going to return a predicate. But what about this predicate? Well, this predicate itself is going to take an input, and then it's going to perform some kind of a check, maybe something like an input greater than value. Well, you could eventually distill this to something very concise like this. And if you notice this, there's one arrow here, but there is another arrow here. At first thought, this could be really intimidating and confusing. But the way to read this is, when you see multiple arrows, just take this part and highlight it and say, I'm not going to look into it. I'm going to only look at this part and this part, but not into the highlighted part. This says, given a value, return that thing. What is that thing? Well, that itself is a predicate, another lambda. Now, only look at the highlighted part. Given an input, I'm going to return that value. So in other words, when you see cascading lambdas, only look at them in different parts. This is one parameter coming in, doing some work and returning that result, where that result itself is a lambda, which in turn takes an input and returns another output, and we can get comfortable with that in this particular case. Well, moving a little forward, let's talk about one other thing that we should be very careful about, and that is avoid shared mutability. Shared mutability is evil. Let me give you a quick example of this. Let's say we have list of numbers 1 to 10 in here, and so in this case, I have these numbers. Let's say we are told, find the, let's say, list of even, find the double of even numbers in the collection. So how do I find the double of even numbers? We could start this with the really going good. We could say numbers.stream.filter, and then we could say, given a number, give me e mod 2 is equal to 0. Well, that says give me only the even numbers. That's awesome. Then I can say map. Given a number, e times 2, that's double. Everything has gone so well so far, isn't it? Then I've seen developers take a complete U-turn. They would say list integer result equals arrays, a new array list, which is empty. Then what they do is the disastrous dot for each, and then they say given an element result dot add element. There's another name for this kind of code. This is also known as bad idea. So in this case, of course, I output the result in here, and the worst thing is you could even try to run this code and argue that the code actually works, isn't it? So let's make sure this is the for each ending. So in this case, what's really wrong with this code? What's wrong with this code is we have started out and you got the result. But look at this. In this case, we did the beautiful filter, we did the beautiful mapping, but then suddenly we are taking the result, which is a shared variable, and we are mutating it. The chance of ever making this code parallel just disappeared. Because if you ever make this parallel, you're going to end up losing some values due to the race conditions. And what's worse is the result is unpredictable. When you have code like this, everything will work fine until it doesn't. And then you're scratching your head. Why did it fail? And then after a long time, you call a colleague and say, I don't understand why this failed. And your colleague says, run it again, and now it works. And then the colleague leaves, it fails, right? And it's very unpredictable. You don't want to do this. What's a better way to do? A better way in this case is to avoid the shared mutability. So what you're going to do is you're going to say collect to list. And you say, put this back into a list for me. You can take care of concurrency issues for me. For this, we're going to use what is called the collectors. So once you bring in the collectors, static Java util stream collectors, that's where the toList is coming from, and you are able to create the list through it. That's a much better way. And finally, to quickly emphasize this, keep lambdas very pure. You don't want to mutate things within a lambda expression. If you mutate things within a lambda expression, you can never be lazy about evaluating the lambdas. One of the strengths of lambda expressions is they can evaluate lazily. I'll give you a very quick example of what this means. Let's quickly take one example to see why this could be a terrible idea. I have 1 to 3 right here, as you can see, and what I want to do in this example is I'm going to take this one and say numbers.stream.map given an element times factor. And I'm going to store this into a stream of integer, and I'm going to store this away into this particular stream. Let's start with this for a second. Okay, great. Then I'm going to say stream.forEach and system.out println. And I'm going to print it. What in the world is a factor? So if I say, in this case, int factor equals to 2, in this example, what am I really doing? Well, let's bring in the stream real quick. So java.util.stream is what I want. So you can see the code produced 2, 4, and 6. Now, in this case, I'm using a factor which is outside of this. I am going to do one thing. I'm going to change the factor to 4, let's say. Java says, no, you cannot do this. Why not? Java wants this factor to be immutable. This is called effectively final. So Java says, don't go there, don't change it. But you know how some programmers are, right? Java says, don't do it. And the programmer says, let me show you how to do it. This is very dangerous, people, right? If you're sitting next to me, quietly move 2 seats away, right? Because what I can do here is, I can go in and say, factor square bracket is equal to new integer and then curly 2. They will write the code and they will have a very evil smile on their face because I have done what Java won't let me do, right? Now what just happened? Java shrugs his shoulder and says, I don't know, I told you no, don't do this. Well, good luck. Now notice what's going to happen. I'm going to go to this code and I'm going to say factor 0 is equal to 0. And then comes the question, what's the output? We can be thinking about it, right? How many of you think the output is going to be all zeros? A few hands go up. How many of you think the output is going to be 2, 4, and 6? You know, we live in a democracy, don't we? I mean, we could just take a poll and see who is the winner, who got the maximum vote, right? But something tells you technology is not democratic, right? In terms of how it works, that is. So when I run the code, notice all of them were zeros. But the point is, we had different people thinking different things. That's a reason why we shouldn't be doing this. What actually happened was, this code is not evaluated right away. It's lazily evaluated only when this is called. This is one of the reasons why lambdas have to be pure. If lambdas are not pure, Java will only protect you a little bit. It's for us to make sure it's pure, otherwise we could be in trouble. So we talked about some idioms, some styles of programming with Java 8 that can either make our code more expressive and easy to work with, or outright avoid problems. So when we write code in Java 8, it's not just about using the syntax, but it's going a little beyond. We should apply some sense as well and do much better than just writing code. Hope that was useful. Thank you.